Okay, so hello everybody, and first of all, thank you for taking the time to come online and watch the fourth in the series of the Powermill webinar sessions. This particular one is all about the plane, line, and point projection toolpaths and how we go about using them and what they're useful for. Okay, so without further ado, quick agenda. These are the toolpaths. On the ribbon at the top in the latest versions of Powermill, this is what the icons for them look like. And here are some of the examples that I'll be looking at as to how we might go about using them. So let's make a start. Okay, so here we have Powermill. I'm going to just select an example here. Here's a part where I'd like to get into an undercut region to maybe machine underneath this overhang area just here. I'm going to undraw the block for a moment and take a look at this from a particular direction. Let's look at that from the end on here and go and create ourselves, first of all, a plane toolpath. So let's go to the toolpath, ask to create a new toolpath, and in here, go for the finishing tab, and the one that we're interested in, you can see here a series of projection type operations. Now, I'm only going to be looking at 3 of these today. In another session, we'll look in more detail at the surface and the curve operations. But let's go for the plane right now. Click OK. And the form pops up for the plane projection toolpath. And the first thing that I'll do is hit the preview button. Now, the preview at the moment is actually underneath the part, so let's undraw the model. And what we see here is an example of what the toolpath is going to look like when we project it. We've got control over that by controlling, first of all, where we're projecting from in the azimuth angle and also in the elevation angle like so. So we can get to pretty much any vector in space that we'd like to project along. Okay, that said, I'm going to draw the model back up and then start to think about how we can specify the limits of it. On this form, there's a location coordinate, so an XYZ coordinate that represents the corner of the plane. And to specify that in this case, I'm going to press the position input button here. We're given a form that we can then simply go and click somewhere on the model. Now I'm looking backwards from the along the y-axis, so I'm going to specify the bottom right-hand corner here and suggest that that is the corner that I'd like to use for the corner point of my plane. And the plane immediately updates to show me that it's now in this position. So then I can go through and have a look at the pattern page. And on the pattern page, we can start to control how big this plane is. So if I change this height value to 200, we can see that the height is represented, in this case, in the vertical plane. So I can then go on to use the blue text here to click and measure off in the Z-axis a distance from, let's say, somewhere around here up to about here. And then likewise in the width direction, specify a position from, it would be the X-axis in this case, from here over to somewhere around here. Okay, well, we've got our plane pretty much described. Let's look at a few more details on this plane. So the next thing I want to look at is the projection direction. Can you see on here that it says direction is inwards? Well, what that basically means is we can project towards the model or away from the model. If I were to go for the outwards option, you'll see that the arrow points in the opposite direction. These 4 arrows on the corner simply represent which way around, if you like, the outside of the plane is. So the outside of this plane would be on the right-hand side here, so outwards would be out to the right, and inwards would be off to the left. So I would like to project onto the model in this direction. Okay, then we can look at details such as whether we're ordering in one direction or the other. So here we're going in a horizontal plane, that's in the U direction. If I go for two-way, we won't really see a difference here, but we're now going to get bidirectional cutting. But if I was to flip the pattern direction from U to V, we would see that we're now going to be vertically cutting. Okay, that's good. So I believe everything's pretty much good to go on that page. We've got the origin set, all of this is all good. We're projecting inwards, we've got our step over set, we're pretty much ready to calculate a toolpath. Okay, so what have we got here then? Well, first thing that I can see is that there's a lot of shielding going on, and we're only going as far as this region here. And the reason for that is the projection plane is actually at this location. So the toolpath will only project as far as the plane position. So what I can simply do there is go to my coordinate at the top here, and then looking at the Y value, I'm going to lock out the other two, the X and the Z, and simply click a point on this back face. When I accept that, you can see now that that is updated. But there's more going on here, and that's to do with the tool axis. Now, I've deliberately done this so that I can show you that the tool axis is calculated completely independently from how the toolpath is projected, because at the moment, although the toolpath is being projected onto that plane from this direction, the tool axis is currently set to vertical. And of course, our Z-axis is pointing from the top down. So although we're trying to get underneath the undercut, we're not giving it the opportunity to do so because our tool axis is still vertical. So what we could do is change that, and there are a range of operations that we can use here, or commands that we can use here to control the tool axis. Now, I won't go into that in too much detail today. There's plenty to cover there in another topic. But let's go and use the lead and lean, which effectively means stay square, stay at 90 degrees to the surface normal of the part. So 0, 0 will be square to the surface normal. I could, of course, take it away from that by entering values in the lead and the lean direction. When I calculate this toolpath now, let's see what we get. So now we get a toolpath that goes all over the part because the projection plane was way back here. But as well as that, the tool axis stays square to our part. Okay. Now that may or may not be what we want. Maybe what we wanted to do was to project in from a particular direction. Of course, what I could do is go to my tool axis, and I could say that I'd like to project from a fixed direction. And rather than use this vector type input here, which is can be quite tricky, it's very simple to press the button here and say I'd like to project in from the negative Y direction. So now when we calculate, you can see that we've projected in from the direction that is negative Y. So if we simulate here, you can see that we're now getting underneath that region quite happily. And of course, we can override that even further and say, look, we want to project in from the negative Y direction, but we don't want the tool to be absolutely horizontal as we saw there. What we'd like to do for the tool axis, actually, I'll show that at a slightly later stage. So you can see we're coming from the left-hand side there. Good, let's have a look at another example then. And now I'm going to take a look at the example that is the projection line toolpath. So imagine this part here, it's the bust of Socrates, the Greek philosopher, and I'd like to create a toolpath that effectively rotary machines around this. So what I can do is go to my toolpaths, go for the toolpath option, and in here ask to go for a projection line toolpath this time. Similar looking form pops up in that we've got an azimuth and an elevation angle. I can preview immediately, and this time what we see is that we now get part of a circle going around a theoretical line in space. I can control that line by dragging these values. I just preview again, you can see that I've dragged that around, maybe do the elevation, that would be more clear. You can see that we've started to drag that in various directions. What I'd like to do is use the location to control where the start point for the projection is. And the way that I'm going to do that is to pretty much look from the side here and just get a quick measurement off. Now, if you look at the bottom left-hand corner of Powermill, just in case you weren't aware, you can see an XYZ coordinate readout, and that is true to the model. So as I walk over the model, you can see it's latching onto whatever the value is on the model. So somewhere around here, looking at about, well, let's say minus 25 millimeters would put us somewhere central about the bust in the X-axis. So let's simply put minus 25 in here, And then in the Z-axis, we're looking at a value of around 375. So let's pop 375 in there. So now when we preview, we can see the frame has jumped into this new position. If we go to the pattern form, on the pattern form, we can start to control exactly how high the preview goes. Now, I'd like to actually machine from the top down. So if I get a rough estimate as to how far it is from in the Z direction from here up to here, we're looking at a value of about 410. So I might round that to 420. And I don't want to start at 100 millimeters up from that origin point. I want to start exactly or finish at that origin point. So a little tip, what I tend to do is I get the XYZ coordinate to the position that is the start of my toolpath, and then that makes using these values in the pattern form here, the height, nice and easy, because 0 would be the value that I entered, and then it's a plus or minus value to go in whichever direction from there for the finish height. The next thing is the azimuth angle. So I'm starting at 0 and going around to 90 here, but I'd like that to go from 0 all the way around to 360. That's good. You can see now that it's gone all the way around here. I'd like to do that in two directions, so bidirectional cutting. So we can now see that on the screen there. And if I go back to this page, we now have control over whether we're projecting inwards towards the part, or if it were a cavity, outwards towards the outside of the cavity. So I'm going to be going inwards here, projecting towards my Socrates head. So then we can think about the tool axis. Remember, that's completely separate. We can control that independently of how we're projecting the toolpath on. For our purposes here, I'm going to go for towards a line again. So it's a similar sort of command, towards a line, and I'll put it in the same place, -25. The Z value doesn't matter here, and 001, I know that that is positive along the Z axis. There we go. If in doubt, you can draw the tool axis and it will show you a line that represents where the tool axis is. Okay, that's all good to go. When I hit calculate now, what we see is a toolpath that will machine our bust for us. Okay, so if we have a look at that, we can see that attaching the tool here, we can see the tool travels around the bust nicely, give us the result we want. Of course, if this were on a rotary table, it would be the part rotating, not the tool. Okay, so that's all good, but I'd like to just change this because I'd like to maybe machine not just vertically through the part. I'd like to maybe align it through a slightly different axis here, maybe through here somewhere. So I can go about doing that. Let's clone this toolpath rather than edit it directly. And we'll go back to the page here for the line projection. And what I'll do is I'll look from above, and I'd like to get some idea, just to undraw the tool for a moment, as to where the highest point on this figure is. So what I could do is maybe use over the graphics area here, use the right-hand mouse key to get the dynamic sectioning, and then simply section from the back, whilst looking along this current view, to get just a region that shows where the highest point is. So it's somewhere around here, it looks like. Obviously, I could be more exact by changing these values to get as precise as I want. So once I'm happy with that, I can go in and click the point and say, well, I'd like to suggest a point around here somewhere. So now the start of my frame is at the top of the figurine just here. So I can go to the pattern page and suggest that the height value now starts at 0 and goes downwards by, let's say, -420. But if I go back to the elevation angle, here, I could just drag it by eye, or if I like, I could be more scientific, and with the right-hand mouse key, and incidentally, anywhere where you can type a value, you can do this. I could go and measure and suggest that I'd like to measure a minor angle that is the measurement between, let's say, this point here, downwards, and over to a position around here somewhere. And I can measure that off. Okay, let's get that something like that preview. Now, I measured this off and I don't really know what angle this is and so on. So when it comes to trying to set my tool axis to be the same value, that could be quite tedious. So here's a little tip for you. If you go for lead and lean, one of the options you've got down here under the mode is to use the preview frame. And our preview frame, just to show you what that is a cylinder. So what we're saying is stay square to the preview frame, which is this line that we just created. So now, when we create this toolpath, you can see that we've got lead lean staying square to the preview frame. And the great thing about this is if in the future I decide that I need to just tweak or change the projection position slightly, the tool axis will happily follow with it because they're linked together. Okay, so now if I was to simulate from here, just to show you, you can see my tool, if I have it drawn, is now coming in from the preview frame direction. But if I wanted to override that further and say, look, don't go below a certain elevation angle, I can go into the tool axis and tell it that I've got a fixed elevation angle of no lower or exactly 20 degrees. So when I calculate now, the preview frame will be back towards the line in the azimuth angle, which is the horizontal angle. But in this direction, let's choose a point here. We've overridden to make sure that we don't go below 20 degrees in the elevation plane. Like so. Okay, so that's the projection line toolpath. Now, while we're on that projection line toolpath, let's have a look at one other example here. And this is a kind of a compound port, if you like, with undercuts in it. Inside there, let's undraw the outside of the model so we can see what's going on. And there we have a typical ball that we might want to get into to machine this region of the ball. And I've got a kind of a wood rough tool here that would get in underneath there, but I need to create a toolpath for that region. So again, I can take advantage of the projection line toolpath. And I can go and first of all set my Z location. I'll do that by simply clicking and locking out the X and the Y and clicking the Z to be on this edge here. Perfect. Incidentally, if you did need to measure a circle, you can do that from here, 1, 2, 3, and it will automatically take the center point as the value that you needed. Happy with that? I'll click OK. So then I can go to my pattern height or pattern size. We know that we want to go from 0 round to 360, like so. And here's another little tip for you. 0 degrees would be along the x-axis. So you can see that's the marker to say that's where my start is. But if I want to start somewhere else, let's say at the other side over here, I could say 180 round to 360 plus 180. And you can see that's 540 in that location. So now when I preview, it's going to attempt to start from somewhere else on the position. The next thing here is the height. So here I'd like to set the height to be starting at 0 and then going down to a depth that is the distance from the top of this feature in Z to the bottom of this feature in Z. There, which is 41. Actually, it's negative. There we go. So all looks believable. All looks good. Tool axis in this case, I do want to be vertical. Let's calculate. The one thing we do need to check is which way we're projecting. The arrows tell me I'm pointing inwards. That's not what I want. I want to point outwards, and I'd like to go one way only. Yeah, that's fine. Calculate. And we get our toolpath. But can you see that we get more here because we're effectively calculating where the bottom of the tool needs to be. So the trick here is whatever the thickness of your tool is, which in this case is 10, here, simply use that as the starting point for the operation. So if I go back to my pattern page, I want to start at -10 and go down to the -41. And now we get what we want. The other thing that we can do for these type of operations is to go and use a lead in lean option. A lead in and lead out option that is very specific to this type of operation, and that is a pocket center. So we're going to lead in and lead out using pocket center. Can you see there that we're now going from the center, moving on, rolling on, going around, then rolling off and back to the center. And of course, there are variations of that. You have what we see here, which is the pattern that is circular. There's also spiral, which is a continuous motion down, and of course linear, which will go up and down, which wouldn't be appropriate in this case, but is available for certain types of operation. Okay. Incidentally, I will quickly show an example of that. I meant to show that earlier, so let me quickly show you that. In here, you can see we have spiral, that's going continuously around, and linear, which basically goes up and down the part. So still machining all of the part, but with a different motion. Like so. Okay, so that's the projection line toolpath. All that remains really is to have a look at the projection point toolpath. So take a look at this part here. What I'd like to do is maybe machine inside this recessed region here. And to achieve that, I'm going to ask for a toolpath that is a projection point toolpath. And as before, we get the opportunity to fill out the location for the frame region, if you like. And in this case, if I just read the values off, we're looking at something like 230 in the y-axis and in the z-axis, something like 300. Of course, you could click these off using this button here if you wanted. So let's preview what we've got. So the start point looks okay, but we've got a positive hemisphere, and we've also only got a quarter of it. So if we go to the pattern, we can tell it that we actually want 0 right the way around to 360. So that solved the first one. The second thing is if we look at which direction we're currently projecting in towards the part, and we want to project out towards the part, which will have the effect on this occasion of projecting from the underside. If you still did want the top side, all you simply do is change the elevation angles. So here if I say minus 90 to 90, we're going to pretty much project in every direction. Good. So that's all set and ready to go. Tool axis, well, let's leave that for vertical for now, and let's go and hit calculate. And what we see is, yeah, we're machining the area that we want, but we're also machining just about everything else on there as well, which is not what I want. So what I can do here is, well, I could use a boundary, or what I could do is take advantage of the thickness form here and create a group that is everything except the regions that I care about. So I'm using the control key just to click out the bits that I actually want to machine. And then I'm going to select a group. I'll go for red, add all of those entities into that group and set that to collision detect only. So now Powermill will not try and machine those regions. It will just avoid them. So if we calculate now, we can see a toolpath that goes and machines the areas that I want. However, it has a vertical tool axis. Now I could go in and change the tool axis to be lead lean using the frame, and it will point back towards the tool axis or the point that I defined on the previous page. But in this case, that's far too severe, and that's not what I want. So here I would actually choose to override and again choose one of the many other options. I'm going to suggest that the tool axis is from a point in space. Now we get a completely separate point. For this point, I'm going to suggest that the tool axis points back to, let's say, 0, 230, but much higher in the z-axis, let's say somewhere around here. That's about 450, is it? Something like that. So let's say 450. If we draw that tool axis and calculate, what we now see is that the tool axis points back towards that region as it machines the area in question. Okay, so what we've just covered there are the plane, line, and point projection toolpaths. And hopefully you can see a use or have learned something and can see a use for those in your day-to-day work. That's pretty much it from me. I'm going to just say a quick thank you for taking the time to come and watch. As before, any questions, type them into the command window that you have available. We won't answer them right now. What we'll do is we'll accumulate all those questions, answer them, and then fire out an email to everybody so they have the answers. Okay, that's it from me. Thank you very much.